Good morning, good afternoon, good evening. I'm Akil Abraham. Today we'll see a correlation analysis on a JASP software. JASP is freely available, user-friendly, which is widely preferable by students and researchers. So today I will walk you through the JASP software. It has amazing features like you can easily run the analysis as well as you can check the plots as well as copy and paste the results to Word documents. So please follow me until the end of the video. At the end also I will tell you amazing tips when writing correlation analysis. Today we'll see correlation analysis on JASP software. Let's open our dataset by clicking on these three dots. Click on Open, click on Computer, and click on Browse. Then let's search where your dataset is. Mine is in desktop. Let me search correlation folder here. In JASP you can import any extensions like this: JASP, CSV, spreadsheet, SPSS, data, SAS, like that. My datasets in SPSS, social media use and mental health. Let me click on that. Now it's imported. So let's click on this is the data view. You can edit also in JASP, but today's session is on correlation. If you are interested on that, I can make another video. So to run a correlation analysis on JASP, let's click on regression. In regression, there are two options to run a correlation. One is classical correlation, and the other is Bayesian correlation. Bayesian. There are different pronunciations. Excuse me if I made a mistake, but I usually like to pronounce it as Bayesian. So I will tell you the difference between the classical and the Bayesian, and also you can run both of these correlations. So for the first part of the analysis, let's click on the classical correlation. Great. Here there is a window. So we'll select our variables, continuous variables, from our variable list to here. Let's see a correlation between ADHD, anxiety, self-esteem, and depression. Now we have a correlation table, correlation matrix, with persons R. That means a correlation coefficient and a p-value. This correlation coefficient provides a numerical summary of the direction and the strength of linear relationship between two variables, like for example anxiety and ADHD. And this person's correlation coefficient, it ranges from -1 to +1. And the sign, that means positive, here it's positive, sometimes it might be negative. So the sign indicates whether there is a positive relationship or a correlation between two variables. That means positive relationship or positive correlation means when one variable increases, the other variable also increases. For example, the increase in anxiety level If it increases ADHD level, that is positive correlation. And for example, if increase in self-esteem level decreases ADHD, it will be negative, but now it is positive. So positive means when increase in one variable is results in increase in another variable. The other is the size in absolute value. That means whether this coefficient is closer to positive 1 or negative 1. That indicates the strength of the relationship between two variables. One means there is perfect relationship. For example, here it's dash, but in some softwares it writes one. For example, ADHD with ADHD it's perfect relationship and the correlation coefficient is positive one or one. So positive one or negative one means there is perfect relationship that explains that shows perfect correlation between two variables, whereas zero means there is no relationship. And the other values, for example, the strengths of these correlation values can be interpreted in several ways. In different statistical books, there are different cut values, but according to Cohen, if this value, the R value, percentage correlation, if it is 0.1 to 0.29, the relationship is small. If it is 0.3 to 0.49, it's medium. And if it's 0.5 to 1, it's large. It shows like that. The other feature in this JASP software is you can flag significant correlations. When you tick on that, it puts asterisks and also puts the meaning of the asterisk. The other nice way also, if you don't want to present like this, you can also display pairwise comparisons. Variables can be presented pairwise like this, only with two variables. So you can use this one as well as the previous table. The other thing here is also you can include confidence intervals. If there is confidence intervals, that's one bonus thing. And also you can include sample size. And here covariance can be also reported in case of necessities. The other, you can also choose the correlation types. Here it by default presents percentage correlation, but Spearman's correlation or Kendall's Taubi also can be present according to the nature of your data. The other thing here also there is alternative hypothesis. By default, choose two-tailed tests. That means it reports both positive as well as negative relationships. But if your study has one tail hypothesis, you can also select from here either positively correlated or negatively correlated. The other also other features also you can see the nature of your data, how it is related pictorially by scatter plot. Let's Click on scatter plot and see how does it looks like. Here it is. That's very nice. As we have seen, the relationship is positive. That means when ADHD increases, and the anxiety level also increases in a particular individual. That's a positive relationship. Also, we can see the statistics. That means the coefficient of R. Now here it is. That's strongly correlated, and we have also 95% confidence interval. And also, you can untick confidence interval if you don't want it. The other feature here it is. You can have also heat map. Click on heat map and see uh, the colored visuals. Here it shows the concentration of the color shows the strength of the association. That's also another important feature. The other assumption check, you can click on Shapiro-Wilks test here, and also you have options for missing values, how to handle a missing value. Here is the Shapiro-Wilks test. The other final point here it is you can copy the table easily to a Word document. Just click on the table, copy, and take it to the Word document. And it gives you a nice table. That's almost publication ready table. Just that needs minimum touch. Oh, wow, that's wonderful table. That has also a footnote, so you can sign note here and include here the table number and heading and the like. So it's very nice. I think I liked it. And also you can copy the picture and you can take it to the Word document and you can publish that. Still, that's also one of the amazing features with this software, JASP software. Thank you for following until the end of the video. Today we have seen a correlation analysis on JASP software, especially that of the classical correlation analysis. And in the next video, we'll see a Bayesian correlation analysis. There are some differences in Bayesian and classical correlations. For example, in classical correlation, it gives you a p-value, which only tells you whether to reject the null hypothesis. Whereas the Bayesian correlation gives you a bias factor. We'll see that in the next video, which quantifies how much evidence there is for or against the presence of a correlation. And these classical tests can't prove evidence in favor of no correlation. That is, if there is a non-significant p-value, it just means insufficient evidence. But the Bayesian correlation can yield a bias factor which support the absence of a relationship. That means now we can you can prove or disprove the correlation much better way with that of the with a Bayesian correlation. So please don't miss the next video. Until that, see you. Have a nice time.